Hello and welcome to part of the How to Make a Game Like 7 Days to Die in Unity series. And in this series we are going to make, what are we going to make? We are going to make individual sort of block terrain. We're going to make it so that individual points of the terrain can have their own texture, basically, which is a prelude to having different types of terrain like rock and grass and dirt and clay and all the other things that 7 Days to Die has. So let's not waste any time. The first thing we're going to do is, in the last video, because we were basically procrastinating and avoiding doing the real game code, we made this little zombie here, and we don't need him for now. So I think, did we make a prefabs folder for him? No, we did not. So let's make a prefabs folder, because we don't want to waste the code that we created for him, and we'll just drag him into there. Now he's already a prefab as far as that's concerned, but that's the prefab of the zombie asset that we used. So let's create a prefab variant, throw him in there, and then delete him from here. And we can delete that cylinder as well, because obviously we don't need that. So if we press play now, we should have some terrain, and it's all fairly uniform, and it's kind of brown when it's slopey, because at the minute it's drawing grass straight down and dirt horizontally sideways. So what we want to do is we want to make it so that we can set individual materials for each individual point of terrain, which is no small feat. So let's go into our code. So the first thing we need is a list for our colors. So make a new list of colors, which we're just going to call colors. This is temporary, so don't get too hung up on what it's called or where it is or anything like that. And then we also need to go down to clear mesh data, which is down here somewhere. Clear mesh data, and we need to remember to clear it. And then obviously in here we also want to set it, and we just do this by saying mesh dot colors. Yep, colors equals, and then colors dot to array, same as all the other lists. Now to set these colors, what we can do is we can go up to our vert for indices function, which I may have gone past. I've definitely gone past there. And in our vert for indices function, we can just say colors dot add, and then we want to say random dot range. We'll pick a random number between 0 and 2, and because we're using integers, that's exclusive, so it will be between 0 and 1. It will be between 0 and 2, but it won't include 2 in its pick. And this is going to be a conditional statement, so we're saying if this random range equals 1, and then the options are color dot black, or color dot, and we're going to go with red, because that's what I did when I'm testing, and I kind of got accustomed to the look. So that sets a random color between, well, a choice of two random colors, but like randomly chooses black or red and puts it into our color array anytime we add a vert. And that's crucial, because not only do our colors need to match the number of verts, they need to be in the same order as the verts. So if the order gets messed up, or if there's more colors or less colors, the whole thing breaks. So now that we've done that, if we go back into our scripts and we pull up our shader, the first thing we want to do is in input, which is here, we want to get the colors. So float for color, and then color. I'm actually not entirely sure if this bit is necessary for a surface shader, but it worked when I did it before, so we're going to leave it. And then down here, all we're going to say, well, actually we'll comment this out, and we're just going to say o dot albedo equals in dot color. So that's getting whatever color value we've put in the current vertex. Now if we go back and we run this, we should find we have a hell of a mess. There we go. So what's happening there is it is randomly assigning black or red to each vertex, and then when we draw it in the shader, we are getting this mess. And what's even more interesting is because we are assigning a random value every time we draw the mesh, if we modify the mesh now by adding or create, by cutting away or adding some more terrain, it completely regenerates the whole texture. So obviously that's no good. So that's the first thing we're going to fix. And so in order to do that, we're going to create a new class, which is going to be to store the information for each, what we're going to call from now on, terrain points, which is essentially the vertex or the point in our terrain map. We're just going to call them terrain points. And to do that, we're going to create a whole class just for that, which we will call imaginatively terrain point. Let's open that up. And we don't need any of this. It is going to be a non-mono behavior class, and the first value we're going to have here is going to be called public float, dist to surface, and by default it's going to equal 1. And dist to surface is basically, if we go into chunks here, you can see that in our terrain map here, we are currently storing somewhere in here, we're currently storing a float. That's what this is going to be. So all of the instances where we're currently calling terrain map, all we're going to have to do to fix the broken references that we're about to get is to just add dot dist to surface, and that's going to be the value that we are currently referencing. And handily, I have some comments that I did that I can just paste in. And then the next value is going to be the actual ID of the texture. And we'll get to what the ID reference is soon, but it's going to be an int, and we're just going to call it texture ID, and by default it's going to equal 0. This one up here, I should just say, the reason that we've set it to 1 by default is because 1 is above the surface of the terrain, essentially, or quote, above the surface. It doesn't necessarily have to be above as in up, but it's outside of the mass that we are generating here, the mass being the terrain. Inside means in the ground. Outside or above means outside of the ground. So 1 basically means air. It's another way of saying air. So by default, we're just going to have this set to 1 unless we tell it otherwise. So unless we say otherwise, there is going to be air there. And then we're going to create a constructor, and we're just going to have the one constructor, and it's going to take in values. And what this does is, because we've only got the one constructor, this is the only way that this can be initialized. And because it's the only way it can be initialized, that means that we cannot create a terrain point without giving it a distance to surface and a texture ID. So that is all we need to do for now. Obviously, in the fullness of the series, there will be a lot more in this class, but for now, for this video, that's all we need to do. So we can actually close terrain point now. We don't need it again. So if we go back into here, and the first thing we're going to do is change this to a terrain point array. And then obviously we have a lot of errors. We can fix this one by changing that to terrain point. And then if we scroll down, this one we're going to ignore for now, because we're going to come back to that one in a second. That one needs a little bit more attention. But these ones down here, we can say this one, dist to surface, this one, dist to surface, and then once again, dist to surface, because that's just referencing that float value that we made, which is just going to take the place of what we were using this for. Now this one, because it's initializing it, we need to make a new one essentially. So we need to say equals, oh, we already had an equals new terrain point, and then in the brackets, obviously, because it's a constructor, we're going to say float y minus this height, because that's the dist to ground, dist to surface value. That's the same value we've been referencing all along, so we don't need to do anything with that. But for the second value, we're going to do what we were just doing with the colors, with the black and the red, but we're going to do it up here. And the way we're going to do it up here is just, instead of picking black and red, we're just going to set the value in our terrain point to either 0 or 1. So in this case, it's going to be random.range, and then the condition is equal to 1, question mark, and then it's 0 or 1. And that's basically, for every terrain point, it's going to be randomly assigned a value between 0 and 1. I don't know why I've done it like that. Right, yeah. This is real smart. Yeah, so we don't need to do all the true false thing. We can just say a random value between 0 and 1. Now, to actually get this information over to our shader, we're going to have to pass it in. To do that, we need some information. Well, we need to know which point we're actually dealing with in our, where is it, vert for index, vert for indis. So to do that, all we're going to do is here, we're going to take in a vector3 int, and that's just going to be the point. And then up here, is it up here? Yep, up here, we change this one. Well, we don't change it, we add to it. We're just going to add in the position. And the position, if you don't remember, if we go up here, the position that we're passing in is a vector3 int, and it is the position of the current point that we are looking at. So we can go back down to here, and we no longer need this random check anymore, because that's not what we're doing. What we're going to say instead is terrain map, terrain map, and then we want point.x, point.y, point.z, and then we're going to get the texture ID, and then again this is going to be a condition, so we're going to say if texture ID equals 1. So it's basically the same as what we did with the red black before, only instead of getting the random value down here, we're getting the random value all the way up here there. But the difference is that this random value is then stored, so that random value is stored in our terrain map, and it's always going to be the same. It's not going to regenerate a different random value every time we redraw the mesh. So if it equals 1, color.black, else color.red. And now if we run that, we should find at first glance that nothing is different. However, now we should be able to modify the terrain without all of the texture or colors, vertex colors regenerating. So the next thing we need to do is to actually change these colors for textures. And to do that, we need to get, well, there's a few ways you could do it, but a lot of them limit the amount of textures you can use. So you could set, if we just go, where is our shader? Our material even. So if you look in our material at the minute, you can see we have these two textures here, and these textures represent the downward texture and then the horizontal crossways texture. You could just put loads of textures in here, but you've only got so much information that you can pass in. So it limits the amount of textures that you could have. It, like, I'm not sure. There's loads of different values. Like you've got multiple texture coordinates, you've got your color coordinates. So there's a lot of values you could pass in, but ultimately there is a limit, and we don't want to have a limit. We want to be able to pass in as many textures as we want. So we're going to do that using a Texture2DArray, which is a bit of a weird one because there's a lot of things that you can and can't do with it. So let's go into, where do we want to go into? We want to go into our shader, and up top here, the first thing we're going to do is create our Texture2DArray, which we're just going to call TextR for texture array, and then we'll call it textures, and it's going to be of type 2D array, and then obviously it's going to equal nothing. And then down here you can see we have this target 3.0. We actually need this to be 3.5. Texture 2Ds are not supported below 3.5 as far as I know. And me saying what I know when it comes to shaders is, well, you just don't take everything I say as gospel. And then the other thing we need to do is say require 2D array. And then the final thing is down here, we want to say in all capitals, unity underscore declare underscore text 2D array. And then we're passing in the name of our array, and that one does need a semicolon on the end of it. So just go back here and check for errors, because you never know when you've mistyped something. Right, okay. So as you can see, if we go in here, there is a Texture2DArray object, but we can assign multiple textures to it. That's not how it works, unfortunately. So in order to do this, we need to assign the textures to it in our code. So we're going to do that through our world script, because our world script, if you remember, is accessible anywhere thanks to the singleton pattern that we did. So anything that we have in our world script that we make public, we can get at from any other script in the game. So let's set the values there then. Public texture 2D array, and we'll just call this terrain textures. And then public texture 2D array. This one doesn't need to have an array bracket thingamajigger on the end of it because it is of type array. And this one we'll call terrain text array. And what we're actually going to do here is we're going to make this hide in inspector, because it will show a field in the inspector that we could edit, but we can't actually do anything with it. But we do need it to be public for what we're going to do later, because as I said, we need to be able to access it from outside of this script through our singleton pattern, which if it's not public, we won't be able to do. So our next thing is we'll just jump down to the bottom here, and we're going to create a new function, and this one doesn't need to be public or anything. And we're going to call it populate texture array. And the first thing we're going to do is initialize our array, and this part's crucial, so pay attention. Text array equals new texture 2D array. Now this part, this is the height and width of the texture. And you might be wondering, oh, hang on, there's multiple textures here. What do you mean the height and width of the texture? That is one of the restrictions of this. All of the textures have to be the same size. You can't put different textures in. So we're actually going to go and check out the textures that we're going to use in a second to make sure they are all the same size. I'm pretty sure some of them are larger than the others, but we can fix that in the import settings. And then the next thing is the length of the array, which is going to be the length of whatever we put in our standard array that we've got in the inspector. So that is going to be terrain textures dot length, and then the texture format dot argbb 32, and then finally false, which is the mip mapping. Now we need to loop through each one. So for int I equals 0, I is less than terrain textures dot length, and then just I plus plus. And then in here, we're going to say terrain text array dot set pixels. And then the pixels we're going to set are terrain textures, the index that we are currently looking at, dot get pixels. And because we're getting all the pixels, we don't need to specify any coordinates or anything, but we do need to tell it 0 for the MIP level. And then I is the index that we are currently setting in our terrain text index, which we want to keep the same as the index in our terrain textures array, because then we know when we put a texture in there, we know which one it's going to be in our shader. And then finally, MIP level again. And then after all that's done, as always with Texture2Ds, you have to apply. So terrain text array dot apply, and that is it for that function. So now if we go up, oh, actually we don't have to go up very far, it's here, into our awake, we need to call that. So populate texture array. Now one thing that is crucial here is the order of execution. You can see this is being executed in awake. If you go into chunk, or it might be not chunk, sorry. If you go into world generator, you can see in start here, we start generating our chunks. But the problem with that is our chunks immediately start trying to, or are going to, when we tell them to in a second, going to immediately start trying to access things, including this array that we are setting, which is going to be a problem if we haven't made that array yet. So because we're putting this in awake, that means that should get called before that gets called. So now to actually use that, if we go into our chunk and we find, where do we do it? Down here, sorry. No, in the constructor. We go to the constructor here, just after we have set the actual material and everything, we can say mesh renderer.material.set texture. And then we want to set the value that we set in our shader, which is text R, and then world.instance.terrain text array, because that is the name of the array that we are passing in. Did I forget to make that public? Or is it just because I haven't semicolon? Oh, it's just because I hadn't hadn't closed the brackets and put my semicolon on the end. So while this isn't actually going to do anything yet, actually before I do this demonstration, well, I'll just run it for a second here. You can see that if we run it and we pick a chunk and we scroll down to the material for that chunk, we can see that we have our texture array and there's nothing there. There would be something there if we had set our, where are they? Set our array here. So I'm just going to give it 3 textures, and I'll just jump into here, and I think 4 was one that I liked. So what we need to do with these is we need to make sure, first of all, that they are set to 1024 maximum, and also they need to be read-write enabled. So just select those and apply that, and then that will be the texture 1 or index 0. I think I believe I liked 1 as well. Ground 1 again, read-write enabled, 1024. And then I shall drag that into, number 2. And then I think the other one that I used last time was 14. Now 14, as far as I recall, is, yeah, you see this is set to 2048. So that would cause problems because it's a different size to the other two. However, because we can change the max size to 1024, and then again, enable read write, that will fix that problem. So then drag that into diffuse. And now if we hit play and we pick a chunk and we scroll down here and we look at the material, you can see there is something in this texture array. So that means that we have set, I mean, we could be setting it entirely wrong and it could be broken, but we are actually setting something, which is what's important. So now to actually use that information. So let's go back into our shader and we need to come down to here. Yeah, here. And what we're going to do is we're going to create 2 new values. And the first one is just an int, and that's going to be called text index. And for default, we're just going to say it to 0. Now, to understand why we're doing this next part, if you remember here, this bit is accessing, we have a float 3, essentially a vector 3 called scale world pos. And that is, it's got your X, Y, and your Z. And we're only using 2 values of it at a time. So we're using YZ here, XZ here, XY there. Now, we need all 3 of those values, as you can see. We're using YZ, XZ, XY. We're using all 3 values of that vector 3. However, the way that we access a Texture2D array is we need to give it first the name of the array. Well, sorry, we call the Unity Texture2D sample function. And then we need to give it the name of the array, and we need to give it a vector 3 or a float 3, but the float 3 is your UV coordinates, so your X and your Y UV coordinates, and then the Z represents the index of the texture in that array. So if we were looking at this one here, we would be looking at 0, so we'd need to give it these 2 values here and then 0. Now obviously we can't modify scale world position because we need all of those values. So what we're going to do here is we're going to create a new float 3, which is going to be called projected. It's not going to be set to anything yet. And what we're going to do with that is we're going to use that and modify it each time to have the correct values inside it. So the first value is projected equals float 3, scale world pos dot y, scaled world pos dot z, and then text index. So as you can see, we're getting this value here, y, and then this value here, z, and then we're getting this value, which is the index of the texture that we want. And then here, instead of doing this, instead of calling the text2d, what we're actually going to call is unity underscore sample underscore text2d array, and then we're going to pass in the 2D array that we are sampling, and then we're going to pass in projected. And that will get us our texture from the array rather than the way we were calling it before. So I'm just going to copy these because I don't like typing. And then we change this one. This one here is X and Z, and then this one is X and Y. And then this line is basically identical for all of them, with the exception of timesing it by pweight.y, pweight.x, etc. And then we can get rid of this. We're not going to need that anymore. And we can bring this back in. And now if we run this, hopefully we should be able to see some texture. There we go. We have some textures back. And if I jump back in here and I change this value, and we don't need to stop the game because it's a shader thing, it should, there we go, it's changed the texture because now it's accessing the second, or is that the third? Well, whichever one, it's accessing one of them anyway. Let's try 2 and see if it breaks. There we go. Right, yeah. So it's accessing the different textures in the array. And as obviously you should have realized, we can put as many textures in this array as we want, which is great. So now let's make it so that we can have individual textures for various parts of the terrain. So to do that, we need to pass in the information into the shader, and we can use any number of the different ways of passing in data. We could use color like we're doing now. However, I'm not going to use color because we might want color later. We might want to use it to tint the terrain or something like that. So I'm going to use the UV coordinates because we're not going to use the UV coordinates because we're doing it this way. So first thing, I'm going to actually get rid of the color thing altogether because it's just, there's no point. We're not going to be using it anytime soon, so there's no point having it in the code. So list, and this is going to be a vector2, which we're going to call UVs, and it's going to equal a new list vector2. And then we'll fix these errors. The first ones, we'll just go right down at the bottom here, and I'll just change these to UVs. And then this one is UV. And then same again, UVs. So now that's all dealing with our UV instead of our other one. And then this one, we're going to add a new vector2. The first value is just going to be the texture ID, which will be 0, 1, 2, or 3 at the minute. And then the second one, it really doesn't matter. We're not doing anything with the second one yet, so it doesn't matter what it is. That's UVs, isn't it? Yeah. And I'm missing a bracket, I believe. There we go. Right, so now that's adding a vector2 where the X value is our texture ID and the second value can be whatever the hell we want for now. It doesn't really matter. And then if we go into our shader again, we need to, and once again, I'm going to get rid of the color thing because we're not using it. We need to create a float2 UV underscore text R, and it has to be named like that. It has to start UV and then it has to be followed by the name of the material or the texture that we want the UV coordinates of. I don't fully understand why it's set up. Like, I don't understand why it's set up like it is at all. So, but that's how it's set up. And then down here, where we set our texture array, instead of giving it a number, we're going to say floor, which is, as you probably know, is rounding it down to the nearest number. And then we're going to say in.uv in.uv underscore text r dot x. And then I'm actually going to plus 0.1 because I don't trust floating point numbers to be exactly correct. Maybe I'm being silly about it, but yeah, if it somehow creeps just under the integer that we want it to be, like if we set it to 2 and it comes in at 1.999999999, floor is going to make it 1, and we don't want it to be 1, we want it to be 2. So hopefully adding 0.1 will make sure that it is the right number. And just make sure I've got my syntax correct there. No errors, that's a good sign. Okay, and the final thing that we need to do is if we go back to our chunk and up where we set our, is it up? Yeah, up here in populate This one, in populate voxel blah blah blah. We want to change this, so instead of a random number between 0 and 2, we're going to say a random number between 0 and world.instance.terrain textures.length. So now it's getting a random number between 0 and however many textures we've got. So let's just quickly give that a try. And there you can see we have different textures in different parts. And obviously it looks terrible right now because it's just random. It's completely random. As you can see, it does go into the terrain. In fact, I will just do a quick thing to show you it working into the terrain. So we'll set this so that it equals 1f by default. And then we'll say if x is less than 5. We did do this in an earlier video. And x is greater than 10. And z is less than 5. And z is greater than 10. If all of that, then set this height to the noise value height. Otherwise, it will be left at 1, which is air. So that should make us a bunch of big holes in the ground in the middle of each chunk. Sorry, I've got this the wrong way around. That wants to be greater than 5, less than 10, greater than 5, less than 10. And then we actually want to be setting the height up here. And then in here, we want to be setting it to 1f. So we're setting it to air if it's inside this value. And now you can see we've got some big ugly holes in the ground, and you can see that the terrain actually does work all the way down. It's not just doing it on the surface. And obviously there's a lot of work to do with the terrain modifying system that was just put there to show you things in action. But yeah, you can see it's working. And obviously it's a bit sharp and jaggedy, but baby steps. So that is the end of the video. And as you can see, we have basics of terrain going. Obviously it's a bit jagged and sharp edged and stuff, but we will fix that in a later video. All that's left to do is to thank all my amazing Patreons. As always, Sugar Daddy / Mama Tier Patreons get an extra special vocal outspoken words said by me because I'm good at speaking. Thank you. And those are Dave Maldine, Reg Reed, Gabriel White, Julio Monteiro, Aaron Clark, and Mr. Drunken Dragon. Drunken Dragon? Dunkin' Dragon? Mr. Drunken Dragon. So yeah, thank you, you guys. You are amazing. And also, obviously, thank you to all the other Patreons and all the people who like, subscribe, share, press the bell thing, and all of that. And all the people in the Discord who are active and chatting away in there. You guys are also amazing. And yeah, that is it for now. And I will see you soon with another video. No, really, I will see you soon. There's another video coming. There is another video coming soon. Bye.